Hi, students and friends. This is your host and teacher Sayyid Ayazuddin Haider, and you're watching Learn and Teach by Sir Ayaz. So I will continue my video for CAI Chemistry 5070 paper 4. I was doing paper 41 and I'm done till question number 2. So I'll continue from question number 3. Student investigates solution W and copper 2 carbonate. A. The test the student does on W are shown in table 3.1. Some of the observations for these tests are also shown. Here's table 3.1. So number 1, add aqueous sodium hydroxide to W. Solution remains colorless. Number 2, add dilute nitric acid, then add aqueous barium nitrate to W, white precipitate. 3, add dilute hydrochloric acid, then add aqueous silver nitrate to W, white precipitate will be obtained. Flame test on W. No color is observed. Number 1, the student correctly concludes that ammonia is formed in test 1. Describe what else the student must have done to reach this conclusion. He definitely has warmed the solution and test the pungent gas produced with moist or damp litmus paper, which will turn to blue. So we will write warm the solution. Test the pungent smell gas. Ammonia is pungent smell gas in this case with moist or damp litmus paper. Paper turns blue. You can check the test from this qualitative analysis list. You see the test for gas here, ammonia. It's turning damp red litmus paper blue. Number 2, state why the student cannot identify the anion in W from the observation in test 3. So look at the statement. The student has added hydrochloric acid and we are getting white precipitate with silver nitrate. Here's a test for chloride ion. This chloride ion. It will definitely give white precipitate with aqueous silver nitrate, but when you are acidifying the solution with dilute nitric acid, not with hydrochloric acid. So if you add hydrochloric acid, it will also contain chloride ion. So that's why you cannot identify the right anion in W from the observation in test 3. So you write hydrochloric acid also contains chloride ion. Cl negative or chloride ions. Number 3, state how the test and observations show that W does not contain sodium ions. So for sodium ions, what is the test? Here's a test for sodium ion. Here's sodium. It will give yellow color. Flame test, sodium ions would give a yellow flame. Number 4, identify the cation and anion in W. Looking at the observation obtained, number one, it's indicating from this information ammonia is produced that it must contain NH4 ion, ammonium ion. What about the next ion? Number two, when you are adding dilute nitric acid and aqueous barium nitrate, we are getting white precipitate. So this test is for the sulfate ion. You see this? Acidify with dilute nitric acid, then add aqueous barium nitrate, white precipitate. So definitely it must contain ammonium and sulfate ion. Ammonium, which is the cation here. Ammonium, not ammonia. Ammonium or NH4, positive. Sulfate or SO4 minus 2 or 2 minus. B, the student adds dilute hydrochloric acid to copper 2 carbonate. A gas and a solution are produced. You are getting a gas and solution is also produced. Number one, state the observation that confirms the production of a gas. Whenever gas is produced, you will see effervescence or bubbling, fizzing. So we'll write fizzing or effervescence. Number two, describe how to do a flame test to confirm the presence of copper 2 ions in the solution. So you have a workable method, that is take a glass rod and make a paste of the solution, solution of the salt with hydrochloric acid. Then bring it to blue flame and you have to notice the flame change. Flame changes color. And in this case, we'll get what color we'll get for copper. We must get blue-green for copper 2 plus ion. So you can write any workable method. Like make a paste of copper 2 carbonate with dilute HCl, dip a glass rod and bring it to blue flame of Bunsen burner. Flame changes to blue-green. Number three, describe one other method the student could use to confirm that the solution contains copper 2 ions. So test for the cations. Where is copper 2 ion? We have copper 2 plus ion here. So we have the test with sodium hydroxide, aqueous sodium hydroxide, and with aqueous ammonia. In case of sodium hydroxide, it will give light blue PPT, which is insoluble in excess. And in case of aqueous ammonia, it will give light blue PPT, soluble in excess, giving a dark blue solution. So we'll write any of these tests, for example, with any one of these. Aqueous sodium hydroxide, blue PPT, blue PPT insoluble in excess. Or you have aqueous ammonia, it also again gives blue PPT. In excess solution, in excess, dark blue solution will be obtained. Solution will be obtained. Last question. Baking powder is used to make cakes rise. When water is added to baking powder, carbon dioxide gas is released. The longer the baking powder is stored, the less carbon dioxide it releases when water is added. Plan an investigation to show which of two different samples of baking powder has been stored for longer. Your plan should include the use of common laboratory apparatus, the two samples of baking powder and water. No other chemicals should be used. Now, your plan should include the apparatus needed, the method to use, the measurements to take, the variables to control, how to use the results to determine which sample has been stored for longer. You may draw a diagram to help you answer the question. Now, in this question, so it's of 6-mark question, I think. Yes, it's of 6-mark question. So how these marks are divided for this question is that you can write one for these, one you can draw a diagram for balance test tube or conical flask. Even you can draw the equipment used to measure the volume in order to get the 1 marks. But you have to label the apparatus. For method and measurement, you can write one of these statements like you are measuring the mass or amount of the sample, then you are adding water, then you are measuring the volume of gas produced, or measuring the time to turn lime water milky, because lime water test is used to check the presence of carbon dioxide gas. Then in case of control, you can write any one of these, like you have must have same mass of each sample, or you can calculate the change in mass, same volume, see the change in volume per gram. You have to calculate this. It should be carried out at same temperature. Then you will measure the total volume of gas produced when there is no further change. Or you will measure the volume of gas produced in a fixed time. The last one is using the result. The sample which produces more gas, which means it has more bubbles, it will take less time to turn milky, or is milkier, which means it is stored for less time. Or you can have Opposite statement, when the sample is producing less gas, it will turn milky and taking more time, which means that it is stored for a longer period. This will cover 4 marks. For the other 2 marks, you can draw one more apparatus and write one of the statements which I have just explained. So first of all, I will start with the statements. So for the method and measurement, you can write measure a mass. Let us write it 1. And for control, I'm writing it 2. And last one, 3. For 1, anyone, measure the mass, measure a mass or amount, adding water, excess water, measuring the volume of gas produced, or measure the time taken to turn lime water milky. For number 2, again, anyone from these. So you must have same mass of samples, same mass of each sample. You can even write amount. Or you can calculate the change in mass. Volume produced per unit here will be gram because the samples are in the solid state. Or you can have same temperature. This will be carried out at same temperature. There won't be any variation in the temperature. Then you can even measure the total volume of gas produced. Total volume of gas produced. Or you can measure the volume of gas produced in a fixed time or in a fixed time. Number 3, anyone. That is for the results, using the results. So sample that produces more gas, more bubbles, sample that produces more bubbles will take less time to turn lime water milky. is stored for less time. For less time. Here you have lots of bubbles, or vice versa. The opposite statement will be the sample that produces less bubbles will take more time to turn lime water milky, which means it is stored for longer period of time. Now coming to the apparatus. Now what apparatus you can draw? You can draw the balance. If you want, you can draw the balance here, or you can draw the test tube. I'm drawing the test tube here, but you have to label the diagram. This is test tube. Or you can even draw conical flask. This is conical flask. Or you can draw a beaker. This will be the beaker. Or equipment to measure the volume of gas produced. In this case, you have gas syringe. Okay, that's all for this question. Thanks for watching. Press like and share my videos. For more videos, subscribe to my channel and press the bell icon.